Okay, so now we're at the point that the OS is installed to the SAN array disk on the UCS blade. So now we're going to reboot the blade and then talk about LAN connectivity as we configure the IP address on the management interface of the ESXi server, the hypervisor, and then we're going to talk about how physically the traffic is going to leave the blade up to the I/O module, from the I/O module up to the fabric interconnect, and then ultimately from the fabric interconnect to the northbound network. Okay, so first let's go back to the UCS manager, and we can see the installer is now complete. So we're just going to hit enter to reboot, and then let the blade go through its reboot process. We should see now under virtual media that the CD automatically unmaps itself once the installer is done. So even though the boot policy we have set to boot first to the CD/DVD drive, since it's unmounted, the end result is that it should boot to the logical unit number, the LUN on the SAN, which is where we have the OS actually installed. Now we'll see that within the scope of LAN connectivity, there's going to be a couple different things that we need to talk about in terms of how the UCS actually determines which direction the LAN traffic is going to go. And we can separate these into two main categories. The first is going to be how the traffic is going from the physical blade within the blade chassis to the I/O module, and then exiting the I/O module northbound on the server ports towards the fabric interconnect. This is going to be controlled from the blade to the I/O module uplink pinning. Then we're going to see that the actual virtual NIC of the server, that is going to be represented by a virtual Ethernet interface on the fabric interconnect, is going to be bound to an uplink port on the FI, so the interfaces we configured as regular trunks. And then we'll talk about how does it determine which uplink it's going to use, what happens if one of the uplink fails, what happens if we want to prefer one uplink over the other. We'll see the specific details of how the connectivity works. Now the first of these, the blade to I/O module pinning, and actually before that I just want to make this clear. When we're talking about the physical connectivity of the fabric interconnects, the cable that is between the two of them, the L1 to L1 and the L1 to L2 cable, this is only used to sync the management plane, or in other words the configuration, but it's not used to sync the control plane, and it's not used to sync the data plane. We'll see that once we start to get into the details here of LAN connectivity, this is going to affect ultimately how the servers can do load balancing through the fabric interconnects, and then we'll talk about what is a supported design, what is not a supported design, what are the cases that we have successful traffic flows, and then what are the cases that we could have traffic black holes, basically dropping traffic, and why that is the case. Okay, so related to the blade to the I/O module physical connectivity, the number of links, by default, the number of links that we're plugging in from the FI downstream on the server ports to the blade chassis is going to control how the traffic is distributed on the physical interfaces from the I/O modules upstream. So in this example, we have only one physical link down from the FI down to the blade chassis. So obviously we only have one physical path in order to exit. If we were to have two physical paths, then we would be choosing even and odd numbers, where blades 1, 3, 5, and 7 on the left of the chassis would be choosing uplink number 1. Blades 2, 4, 6, 8 on the right hand of the chassis are going to be choosing uplink number 2. If we have 4 links, then we're going to be using every other blade, where blades 1 and 5 would use uplink 1, blades 2 and 4 would use uplink 2, and so on and so forth. We can then have 8 links, okay, assuming we're talking about the 2208 I/O module. In that case, each blade is going to have its own dedicated uplink. But the problem that we're going to run into with this from a practical point of view is that if blade number 1 is pinning to the first interface, okay, so we have the physical blade traffic is going to go up on this red port going up to fabric interconnect A. If this link physically were to go down, like the optic goes bad or there's a physical cut in the cable, the blade is not going to automatically repin or reload balance its traffic to another physical port. The only thing that we can do is send traffic to the other fabric, assuming that we have a feature configured on the virtual NICs, which is going to be called fabric failover. So in most typical cases, you'll see that you do not want to leave the default behavior of the UCS with the I/O module to the FI pinning, because we can't load balance the traffic between multiple physical ports. If we lose one interface and we're using 8 physical links, that actually means that you lost 4 interfaces. because the system only supports pinning in variations of 1 uplink, 2, 4, or 8. So in most typical cases, what you want to do is simply tell the system that we're going to use a port channel, and we're going to take all of those interfaces that are going from the FI down to the I/O module, and we're going to run them as one logical interface. Now, this is not going to be controlled from a configuration point of view. When we're talking about the blade to the uplink pinning, if we're not doing a port channel, the decision is going to be based on how many physical blades we have inserted into the chassis and how many physical uplinks we have going from the I/O module up to the FI. So this means that if you wanted to move what uplink it's using, you would either have to re-acknowledge the I/O module, which is essentially like rebooting the I/O module. It's going to drop network connectivity, then it's going to reboot, repin, and then restart to forward the traffic, which of course is going to be a disruptive change. It's the same as like unplugging the links. Or if we're using a port channel, then if we add new interfaces to the channel or interfaces are removed, then the system is automatically going to load balance it based on the channel balancing method. Okay, the key about this though is that by default, the system is going to do this static pinning configuration. It's not going to be doing the port channel pinning. And where we can see this from the CLI is that if we were to go to the Fabric Interconnect and let's connect NXOS, and then just like we saw previously on the 5Ks, we're going to say show FEX to show the Fabric Extender, or in other words, the I/O module. Okay, so I/O module in this case is C6508, which if we look at the show FEX detail, specifically this part number is the 2208, which has 8 physical 10 gig uplinks and then 32 physical downlinks in the chassis as backplane Ethernet that are connecting down to the blades. But what we can see here from the output of the show FEX detail is the downstream interfaces, so the FEX ports here on the left that say 111, 112, 113, this is going to go through 1132. And notice here that all of these interfaces are using the same physical uplink, which is port 1/1. Even though if we look at the show run interface E11 to 2, from the GUI point of view, we had configured both of these interfaces as server ports. Notice that there's a configuration difference between the two links. The first interface says that the switch port mode is FEX Fabric, which means we're connecting to a Fabric extender. We're using that VN tag special frame format, where the second interface is configured as a trunk port. So this means that by default, if you leave the blade to I/O module pinning alone, so the default connectivity policy, when you acknowledge the chassis, only the first interface is going to be used for forwarding traffic. Now, assuming that we want to use all links, okay, which doesn't make sense to plug the links in if we're not actually going to use them, it means we need to do one of two things. We either need to re-acknowledge the I/O module so that both of them are statically pinning, or we can change the connectivity policy to use a port channel, and then we'll see that interfaces E11 and E12 go into a port channel. The port channel is going to say switch port mode FEX, and then the pinning is going to happen to that. Okay, so before we configure the port channel, let's look at the static pinning. So we're going to go back to the UCS manager, and we're going to go under equipment. Then we're going to go to the physical chassis. Okay, so equipment chassis, and then we're going to go under the I/O modules, and we can see that we have 2 physical connections. Okay, we have 2208 on module 1, we have 2208 on module 2. It has backplane ports versus the fabric ports. The backplane ports are the ones that are going down to the servers. Okay, notice the interface role says it's server. And then the fabric ports, these are going to be the ones that are going upstream towards the fabric interconnect. Okay, so this is from the I/O module itself. It's saying ports 1 and 2 are going to be the fabric ports going northbound, and then the other interfaces, the backplane ones, those are going towards the servers. Okay, so in order to control this config, we can do it 2 different ways. We can go under equipment, and then under policies, and the chassis and FEX discovery policy. What this says here is how many interfaces do we have to have physically wired from the Fabric Interconnect southbound to the I/O module, or southbound to the chassis, in order to find the chassis, in order to discover it. Okay, so the default is 1. which means as long as you have one link plugged in, you're going to be able to find the chassis. If you were to increase this, let's say, to 8 links, it means that any chassis that have 1, 2, or 4 links are going to be ignored. Only chassis that have 8 links are going to be discovered. So in most typical cases, you would want to leave this drop down the default, which is 1 link. But instead, what we would want to do is to change the link grouping preference to a port channel, which means that we're going to find all of the interfaces, put them into a channel, and then we're going to load balance the traffic between the multiple physical members. Okay, but assuming that we don't want to do this, we're going to leave this alone. What we're going to now do is to go under the chassis, we're going to go under the I/O module, and then we're going to acknowledge the I/O module. Okay, it says when you do this, this is going to rebuild the network connectivity. Currently, there are 2 active links to Fabric A. Okay, basically this means that it's rebooting the I/O module effectively. Okay, so notice those green ports, those are the ones that are physically plugged in from the IOM to the Fabric interconnect. So if we go back to the CLI and then let's look at the show FEX. Okay, the extender is still attached, and let's look at the show FEX detail. What we should see here in a second is that the Fabric interfaces, so port 1.1 and 1.2, should now be distributed between the multiple downstream server ports that we're using from the Fabric extender or from the I/O module inside of the Blade chassis that's going to the actual physical adapters, okay, like the VIC card of the servers. So it takes a minute to do this when you do the re-acknowledgement. But what we should see here, so let's say show FEX detail pipe to include, and let's say ETH1/1 or ETH1/2. And what we should see here in a second is that some of these physical links are going to be distributed to ports 1, 2. Okay, it's effectively going to be every other blade that we have inserted into the chassis. Okay, now remember I mentioned that the physical blade chassis can handle 8 half-width, half-height blades. Okay, so the small ones like B200 or B22. And then we have 32 interfaces that are going from the I/O modules into the chassis. Okay, this is 32 ports on the A fabric and 32 ports on the B fabric. So if we think about this from a physical point of view behind the scenes, we have the Fabric interconnect that has the multiple physical interfaces that we have configured as server ports. Okay, so we have Fabric interconnect A, we have 2 interfaces that we configured as server. This is physically going down to the I/O module. Then behind the scenes, the I/O module is going to have 32 interfaces that are going down to the blades. Okay, so blade 1 all the way through blade 8. And then we're going to have the same thing on Fabric interconnect B. We have 2 links in this case going down to I/O module B. Okay, so we have IOM A, we have IOM B, and then we have 32 other interfaces that are going down to the blades. So with this chassis design and the second generation I/O module, each blade has 4 lanes of 10 gig Ethernet on each fabric. So 4 times 8 being 8 blades per chassis, 4 links per blade, 32 links total. So this means that we can have up to 40 gig access on the A fabric and 40 gig access on the B fabric, which is typically used when the blade has a virtual interface card 1280 or VIC 1280. Okay, VIC 1280 means that we have 4 by 10 that are going to the A fabric, and we have 4 by 10 that are going to the B fabric. So 40 plus 40, 80 gigs of total access. And then assuming that we have enough physical interfaces going from the I/O module up to the Fabric interconnect, usually this place here is going to be where the bottleneck of the system is. So either the links from the I/O module to the FI, or the links northbound from the FI to the rest of the layer 2 and layer 3 network. That's where typically the oversubscription is going to happen, because we have potentially 320 gigs of downlink bandwidth from the I/O modules on each fabric. But on each fabric northbound, we can only have up to 8 channels of 10 gig, where we have 32 channels of 10 gig going down. Or in other words, assuming everything is 100% populated, we're going to be oversubscribing in a ratio of 4:1. Okay, but eventually here, once the FEX re-acknowledges, we should see now that it's going to do a load split. Okay, so interfaces E11 through E14, these are physically going to blade number 1. Interfaces 5, 6, 7, and 8, these are physically going to blade number 2. 9, 10, 11, and 12, these are going to number 3. 13, 14, 15, 16, these are going to number 4. And notice what's happening is that every other blade is being pinned to a separate uplink. So blade 1 is getting port 1, blade 2 is getting port 2, blade 3 is getting port 1, blade 4 is getting port 2. Now again, the disadvantage of this design is that if Ethernet 1.1 physically goes down, so the link from the I/O module northbound to the FI, the virtual NIC is not going to automatically repin on the same fabric. Okay, so essentially from the OS's point of view, you lost your network connectivity path on A. You would have to have some sort of failover at the OS level or fabric failover at the hardware level of the virtual NIC in order to move the traffic over to the B fabric. Which is why in the vast majority of cases, we're not going to do it this way. We're going to configure a port channel as opposed to doing the static pinning. Okay, so for the port channel option, there's two different places that we could do this. We could either go under Equipment, and then under Equipment, we're going to go to the Global Policies, and globally, we're going to change the link grouping preference to port channel. Okay, this is going to affect both Fabric A and Fabric B. The other option would be to go under the individual chassis and then set the link grouping preference on a per I/O module basis. So under Equipment, Chassis, Chassis number 1, then the Connectivity Policy, we can say for Fabric A, do we want to use a port channel or do we want to use the global setting? Okay, global setting right now is doing static pinning, same as for Fabric B. Now in a real design, the only typical case that you would actually do this is if you have a Generation 1 I/O module, which is the 2104, and the 2104 did not support port channeling. But assuming that you have any relatively new or recent, within the past couple of years, hardware in the UCS chassis, which would be the either Gen 2, 2204, 2204, 2208, or the Gen 3, which is the 40 gig I/O modules, then it's not going to be a problem. Pretty much everything should support port channeling in most UCS domains. Okay, so instead of setting this on a per chassis basis, I'm just going to set this globally. So I'm going to reset the value. So go back to the default. We're going to go under Equipment, Equipment, then under Policies, set the link grouping preference to port channel, save the changes. Then if we go to the CLI and we look at the show run on interface E11 to 2, we see that the chassis is associated, the FEX associate is going to both physical links, okay, so Ethernet 1.1 and Ethernet 1.2, but notice that this is not yet configured as a port channel. So anytime that you change the static pinning to a port channel or move from port channel to static pinning, or you want to statically repin, it means that we need to either re-acknowledge the I/O module or re-acknowledge the entire chassis. So acknowledging the I/O module, you can do that separately, A versus B. The use case being that you shut down A and let it reboot. All the servers fail over to B and they continue to forward the traffic. A comes back, they repin to A. You then reboot the B fabric or the B I/O module. All the servers fail over to A. Then essentially you can update the connectivity policy without having to take an outage from the traffic point of view of the servers. Okay, but in this case, I'm just going to reboot the entire chassis or re-acknowledge the entire chassis, which is going to do both Fabric A and B at the same time. So the way we do this is we're going to go under Equipment, we're going to go under Chassis, we're going to go under Chassis number 1, and then under General, we just hit Acknowledge Chassis. And like it says here, it says, are you sure you want to do this? This is going to rebuild network connectivity between the chassis and the fabric. Okay, talking about the fabric interconnect. There's currently 2 active links on A, there's 2 active links on B, so it's effectively rebooting both I/O modules at the same time. So if we were to go to the northbound switches, in this case 5K1 and 5K2, what we should see is that the storage adapter, when we look at the show Floggy database, we should see that the servers log out because both the storage and the network traffic is riding over the same I/O module. That's why it's really important here from a maintenance window point of view that you don't have any servers that are doing reads and writes to the remote disks, either through Fiber Channel, FCOE, or iSCSI, because when you reboot the I/O module, it's basically the same as unplugging the disk from the server. Okay, so what we'll see is, and there's a question here, how long will it disrupt traffic? It's usually like 10 to 15 minutes. So it's not a quick process to do it. It also depends on whether it needs to upgrade the firmware of the I/O module or not. And that's going to be based on whatever global firmware packages you have installed on the FIs. Firmware updates we're going to talk about a little bit later, but it works the same way as the 5K association to the 2K works. That like on 5K1, if we go to global config and let's say logging monitor 7, terminal monitor, and then say feature effects, we should see that it's going to discover the fabric extenders. Okay, in this case, it says ports 1/21 and 1/22 go to a fabric extender. And we'll say interface E1, 21 to 22, switch port mode, FEX fabric, FEX associate number 101. Then look at the show FEX. This is the same type of output that we see on the fabric interconnects going down to the I/O module. Then if we look at the show FEX detail, once we go through the booting process, we go from connected to, well, first we go from discovered to connected, then to online. What the parent switch is trying to figure out is what is the version of code that the fabric extender is running. Okay, so this was output of show FEX detail. When we look at this on the fabric interconnect, the UCS FI, and say show FEX detail, we'll see that these outputs are almost identical pretty much on a one-to-one basis, that it says, so what is the FEX's version? Okay, so right now the version is 5.03 and then subversion 3.11. This means the UCS manager version is 3.1. And the northbound switch is running this version of code. Then assuming that the FEX matches, we don't need to change the software version. But if I were to upgrade to 3.11F, whatever the next maintenance release is, it means that when the I/O module comes on and we re-acknowledge it, it's going to have to download the firmware to it, which means it's going to take even longer to do. Okay, so it's something that normally you would have to do during a maintenance window in a real design. Okay, what we also notice here now is that there's port channel 1025. Port channel 1025 should be the one now listed as the fabric port once the FEXs are done fully acknowledging. Okay, so show FEX detail again, and then towards the bottom we should see, let's say show FEX detail pipe to include P01025. Okay, port channel 1025 is the number that it generated. And we should see here in a minute that all of the downstream interfaces to the servers are going to be pinned to this port channel. Okay, same is going to be true on the 5Ks as we talk about its links down to the standalone C servers that are connected on the fabric extenders. If we show FEX detail, we see that by default we're doing static pinning, which means that the uplink interfaces are not going to be load balanced between. So in this case, we have a C200 server that is connected, dual connected to two different fabric extenders. So we have 2K3 and we have 2K4. 2K3 and 4 are then going up to 5K1 and 5K2 respectively. Okay, so there's straight through links and then there's also diagonal connections. But the key here is that I have multiple ports that are going from the 5K to the extender. This would be the same logical relationship as I have from the fabric interconnect that is going southbound to the I/O module. Now behind the scenes, these are literally the same platform. The 6200 fabric interconnect is the same as the 5500 Nexus. It's just running a different version of software. And the same thing is true with the I/O module. The 2208 is the same as the 2232P, the Nexus 2000. The only difference is that it's in a different form factor. That instead of physically wiring the cables from the fabric extender down to the rack-mount servers, we're indirectly wiring the cabling by plugging the I/O module into the backplane of the chassis, and then we have those backplane Ethernet ports that are going to connect from the server interfaces of the I/O module physically down to the adapter of the blades. Okay, so let's check again. Here's show FEX detail, actually on the fabric interconnect. And we can see that it is starting to pin the links, but it's not an immediate process. There we go. Okay, so now ports 111 and 113 are pinned. They're currently still down though, so the server would have to reboot in order to actually use those. Okay, now we can see it's starting to add the other interfaces, and then we should see the interfaces to the servers we're actually using are going to come up. So notice in this case it says we have ports 13 and 15 being used. So if we map this out from kind of a physical view point of view, we would have the I/O module that's physically going down to the chassis. Okay, so we have links 1, 2, 3, 4. These are going to go to blade 1. We have 4, 5, 6, 7, 8 is going to go to blade number 2. 9, 10, 11, 12 is blade 3. 13, 14, 15, 16 is going to be blade number 4, which in our particular case, blade number 4 is powered on, which is why ports 13 and 15 show as up. Okay, so this is 1 through 4. This is 5 through 8. This is 9, 10, 11, 12. And then this is 13, 14, 15, 16. So notice here that the other servers that aren't powered on, like blade number 1, the interfaces are currently down. But additionally, notice that interfaces 14 and 16 are not listed here, which are part of the pinning for that blade going back to the I/O module. Now, the reason in this case that it only shows 2 of them is that the physical VIC card, the virtual interface card that I have installed on the blades, is not a VIC 1280, which means it's not using all 4x10 channels on A and all 4x10 channels on B. The way that we could see this from the UCS manager would be to go to the inventory of the servers and then look at the actual adapter that is on the blade. Okay, so we're going to go to the equipment tab, then we're going to go under equipment, then server. Okay, so server 4, and server 4 we should see is associated to a service profile, so overall status is okay, and the service profile is Brian profile 2. And then if we open up the server under adapters, it has 1 adapter. It says the part number is VIC 1240, where if we were to look up the data sheet for this, so let me open up my web browser, and let's search VIC 1240 datasheet. It says that VIC 1240 is a 4-port, 10 gig, FCOE capable modular LAN on motherboard MLOM designed exclusively for the M3 or M4 generation of UCS Blade servers. What this means is that it has 40 gig total, 20 on A, 20 on B, or in other words, we're only using 2 of the traces that go to the A I/O module, 2 of the traces that go to B. The other 2 traces would be used if we added a port extender to the blade, or if you were to remove the VIC 1240 and then replace it with a VIC 1280. So the pinning is always going to depend on what is the actual physical adapter that we have inside the server, and this is what the card looks like. On the other side of it, it has a pinout that you physically plug into the board. So it's essentially the same as a PCIe network adapter, like you have your regular Intel NIC that goes in your desktop, but it's a different form factor in terms of the interface that they're plugging it to the motherboard. But when you look at this from a standalone server, this would be the equivalent of like a VIC 1225, or I want to say it's a VIC 1335 is the newer one. Which is going to be, the VIC 1225 is the 2-port 10 gig adapter, and I want to say 1335 is the 2-port 40 gig adapter.